All right, welcome back to class. Today we're going to be doing adding and subtracting polynomials, which basically is just being able to combine your like terms and paying attention to the signs on each of them. So first we're going to go over a little bit of what polynomials are. So a polynomial is the sum or difference of many monomials. The monomial is just one term. So the highest exponent of a polynomial is called a degree, the degree of the polynomial. And in standard form, we want to write the largest degree first, then in descending order. So we want our degrees to count down. From left to right, they would be counting down. So when we're writing these polynomials in standard form, we want to take the largest degree first. So I have 5, 0, 1, 3, and 2 as my quote-unquote degrees, the exponents. So the largest one is already the first one, negative k to the 5th power. Then we would want a 4th power, looking at all my exponents. I see that I don't have a 4th, so I would skip down to the 3rd. Then the 2nd power. Then the 1st power. And then last is the 0 power, which is the same thing as a constant, so that -1. So make sure when you are rewriting in standard form that you are putting them with their signs that they originally had and not changing their signs. Then on number 11, we'll do the same thing, but now we've got more than one variable, so we do have to be careful. So the cube is my largest, so 4a cubed goes first. Then we typically put them together, so a and b together. This squared is larger than just ab, so positive 18a squared b squared. Then the 7ab, since a and b just have a power of 1. And then we put our last one, which looks like it would be out of order, but when we have more than one variable, we want to make sure that we have the variables in alphabetical order. So a alone, ab, and then b. And then on this last example, we have 5xy squared. So again, we have two different variables. So we're going to go alphabetical order, and then that means the combined ones will be right in the center. So x comes before y. We're looking for the highest power of x. So negative x squared will be first. Then we want our combined x and y. We're going to do largest degree of x, since I have two of those, first. So largest degree of x first means 9x cubed y. Then the positive 5xy squared. Then our negative y to the 4th, since that one's by itself, and constants are always in the end. So it is a little trickier to do standard form when you have the double variables in there, but with our on the first one, number 10, when you have one variable, just make sure that your powers, your exponents, are counting down. So when we are classifying polynomials, which we will start next week a little more, once we are classifying, it is classified by the degrees. So remember, the degrees are the highest exponent, so the largest exponent that they have, and then the number of terms. So our degrees have different names. So a 0-degree polynomial is a constant. That means we have something like 1x to the 0 power, and anything to the 0 power is just 1, so that's the same thing as saying 1 times x, which is just, not x, sorry. It's the same thing as saying 1 times 1. So let me write that, which would just be 1. And that is a constant. Then our first degree would be something that is linear, so a straight line, and that would be something like x or 2x or anything like that. Then the second degree, those are our quadratics, which we work a lot with in Algebra 2. That would be x squared, or any coefficient x squared, so any number, let's say 8, x squared, anything like that. A degree of 3 is a cubic function, and that's going to be x cubed, or any number, so let's say 4 x cubed. Those are some examples. When we get to 4 and 5, these are things that we don't typically hear. Those are quartic and quintic polynomials. And a lot of times we really only deal with up to here, but be aware that these do have names. And that would be like x to the 4th and x to the 5th. Then when we are classifying based on the number of terms, these also have names. So if it has one term, that's called a monomial. If it has 2 terms, it's a binomial. 3 terms, think of a bike. So if it has 1, it's a unicycle. If it has 2, it's a bicycle. And if it has 3, it's a tricycle. So if it has 3 terms, it's a trinomial. And then if it has 4 or more, we just call it a polynomial, meaning it has more than 1. And an example of a monomial would be something like 2b. Even though it looks like there's 2 terms, our terms are separated by plus and minus. So if there is multiplication between them, then they are still considered one term. A binomial would be something like 2b plus 6. So we have that plus that is separating it. A trinomial would have 3 terms, so we could say 2b plus b squared, not in standard form, plus 6. Let's use 8 because 6 kind of looks like a b. So plus 8. And then a polynomial would be 4 or more, so we could say b squared plus 2b plus 8 plus c. There are 4 terms separated between plus signs. They could have minus signs, but we just count based on how many things there are that are separated by plus or minus. Now when we are adding or subtracting polynomials, again, we're just combining like terms. So that first step, combining like terms, watch out for subtraction because that's going to change the signs, and then make sure that we write our answer in standard form. So I like to make sure that my answers are in standard form while I am doing the problem. So I will start by combining the highest degrees or the highest exponents first. That way I know they're going to be all the way in the front. So on number 1, 3x squared plus 11x plus 4, all of that plus negative 5x plus x squared minus 13. So the first thing I'm going to do is box off my x squared, so let's zoom in a little more with their signs, if I can make them fit. Then just my x's, I put them in a circle. Then I'm going to put my constants in a triangle. So very much like what we did, or what you might have done in Algebra 1 when you needed to combine your like terms and you needed to see what is the same. So the highest degree that I see is the highest exponent, so it's going to be the squared. So I have 3x squared plus x squared, so 3 plus 1 gives me 4x squared. Then the next would be just an x term, so I have 11x an 11x minus 5x. Make sure we're keeping their signs the way they are, which would give me a positive 6x. And then my constant would be last, so 4 minus 13 gives me negative 9. And I know it's in standard form because I counted down with my degrees. If you needed to check, you would say, well, my highest is 2, the next one is 1, and the next one would be 0, so it is in standard form. On number 2, we're going to do the same thing. I'm going to mark off which ones are the same by using different shapes. So that's a cube, and scanning through here, I see no more that are cubes, so I'm going to use a different shape for my square, and I'm going to use a different shape for the ends, and then I'm going to use a squiggly line for the constants. The highest degree, the highest exponent that I have is the cube, so that's going to go in the front. It is the only cube, so nothing on it will change. I'm not combining it with anything. My next highest exponent is a 2, and I have negative 4 and negative 2, so negative 4 minus 2 gives me negative 6n squared. And then the next one would be the ends. So 2n plus n gives me 3n's. And lastly is always going to be any constants that we might have. So minus 10 plus 7, which is negative 3. Combined all our like terms. We know we're in standard form since we went highest degree to lowest. That would be our final answer. Now on numbers 3 and 4, we have subtraction. And when we are subtracting, we're distributing a negative 1. So we have to make sure that each of those becomes a minus. So I like to rewrite it. Nothing's changing with that first polynomial. So it stays exactly the same. And then I'm going to rewrite the second one by changing all of their signs. So now what I'm going to do is the same thing that we did on the problems before by marking off which ones are the same with these shapes. So here I have a cube. I'll scan the problem for another cube. I don't see one. And I have a square and another square. Okay, doesn't have a visible power on it because it's a power of 1. And then a constant. My highest degree, my highest exponent is a 3, so 5k cubed, I don't see another square in there, so 5, well, I could call that a rectangle because square sounds like a power. So I don't see another rectangle that I've created, so 5k cubed is the only cube on there. Then my next highest exponent would be the square. So negative 2k squared minus 2k squared is negative 4k squared. Then just my plain k's without a visible power, so 2k minus 2k would be no more k's. I'm not going to write that. And then the constant. So notice I didn't say plus 0k minus 0k or whatever. I just left it out of my answer. So we could write this but what's the point of this? So instead of including the 0k, I just went ahead and went straight to the constant. So it is okay to skip your powers if they don't exist in your problem. So just be aware of that. On number 4, we're going to do the same thing. So I want to distribute that negative across all of these terms. I'm going to rewrite the first one since nothing's changing. And then when I distribute a negative, I'm just changing all those signs. So minus 1 minus 2y squared plus 5y plus y cubed. So the first one that I see, I'm just going to go with as a rectangle is a y. Any other terms with a y? I have 5y. Then 4y squared. So we'll look for another term with a square. Then I have two constants here. And here we have this y cubed by itself. So I'm going to combine my like terms, and I'm going to make sure that I'm in standard form. So my highest exponent is an exponent of 3, and it is the only one in the problem. So it's going to be first. The next one would be a exponent of 2. 4y squared minus 2y squared is positive 2y squared. The next one would be just my plain y's. So y plus 5y gives me 6y's. And then negative 3 minus 1, which is negative 4. Since I counted down with my degrees, I know that I'm in standard form. Now on number 5, subtract this amount from this amount. Now ignoring that it says all of this, what if it subtracts 10 from 15? Would you go 10 minus 15 or 15 minus 10? Well, if we're subtracting an amount from an amount, then I need to be taking 10 away from it. So since 10 was the first one, 10 became the last one. When I rewrite this problem, I am subtracting this first amount from this second amount. So I am taking 8b squared plus ab minus 2a squared and subtracting negative 10 8b plus 7a squared minus b squared. So just like in the problems before, I need to distribute this negative. Keep the front the same. And you'll notice that I remove the parentheses when I rewrite the first one, and that's because after this step, once I change the negatives on the second one, then we're just combining like terms. So I do not need to have that separation between the problems anymore. So I'm going to change all their signs on that last set by distributing that negative. And then I'm going to mark off which ones are alike. So the first one that I have is a b squared. So I'm going to look for one that says b squared. The second one that I see is a and b together. 10ab. And then the last one is an a squared by itself. So remember, when we have more than one variable, we're going to go alphabetical order, highest degree in the front. So alphabetical order, a is going to come first. Highest degree of a, highest exponent on a is squared. So we have negative 2a squared minus 7a squared. So negative 2 minus 7, negative 9a squared. Then we're going to put our terms together for the middle. So the AB will be right in the center. We have AB plus 10AB. So imagine that AB is one variable. If that said, let's say Z plus 10Z, we're going to add 1 to 10. We would have 11Z, which would be 11AB. So whenever your variables are stuck together, like A and B, make sure that you keep them together. And then the last one would be the later term in the alphabet, and then its highest power. So 8b squared and b squared, we would add them together, 9b squared. So then for your homework, you have these 16 problems. The ones on the top half are addition, and then the ones on the bottom half are subtraction. And I will be posting half of the answers, so the left side will be posted for you to check your answers at the end of the week. So the end of the week this week is the 8th. Just so you to be able to go back and check and say, well, am I doing this right? So make sure that you turn that in. And that is all for today.